Hey guys, in this video I am going to show you how to find the equation of a sphere given its center and the fact that it's tangent to the xy plane, okay? So I hope you've had a great day so far. Now we're going to do some mathematics, so how's everybody doing? Yay, okay. He's going to assist from time to time. Now, let's begin here. So we're finding the equation of a sphere given its center, and the center of our sphere is the following. Let me move this. -2, 1, 1. So this is the center of our sphere. And we are told that this sphere is tangent to the xy coordinate plane. So the sphere is tangent to the xy coordinate plane. So before we do anything else, a sphere is roughly Pinko's head over here, right? It's roughly that shape. So because it's tangent to the xy plane, you may have trouble visualizing the sphere. So what I will do is draw a small coordinate system. Labeled axes as x, y, and z. That's standard. When you draw a coordinate system, draw the lines this way. This is what we call a right-handed system. Okay, so if Pinko were at the origin here, this falls along his left arm, right? And the y falls along his, the way he's standing relative to you, this is like his right arm. So the x-axis falls along his right arm, and the y-axis falls along his left arm, okay? So this is what we call a right-handed coordinate system, okay? The way he's standing, from your perspective, this is his right arm, the x-axis falls along the right arm, the y-axis falls along the left arm. Like this and like that. So now that we have this, the center of the sphere is -2, +1, +1. So in fact the x is negative, so it's roughly somewhere back here, and then the y is +1, so that is about here, and the z is also +1, so maybe the sphere is kind of like this, somewhere over here, okay? Roughly what we have is perhaps a sphere that looks like this, but the idea that is crucial is that it's centered at this point and it's tangent to the xy coordinate plane. Okay, so this is an important idea. That means imagine the xy coordinate plane is below it like this. I'm drawing a small portion of it, it's tangent to it, it's touching it at that point, say, okay? So with this in place, what we can do is this. We can identify the radius of the sphere. You see, the radius of the sphere is simply the z-coordinate of the point. Okay, so the radius of our sphere is simply the z-coordinate of the point. Okay, of the center point. So, with that in place, we can write the equation of the sphere as follows. Let's review the basic concept. X minus x0 squared plus y minus y0 squared plus z minus z0 squared equals r squared. Now we make the replacements, so we will write x minus, and now comes the important step of replacing. x0 is like the -2, y0 is like this one, and then z0 is like that second one over here. Okay? These are the coordinates of our center point, which is right there in the sphere. So we write x minus a -2. Okay? X minus a -2. Parentheses. And square the whole thing. Then we write y minus a +1. Okay, so all I'm doing is replacing it first, plus z minus z0, so that's another positive 1, and the whole thing squared, and all of this equals 1 squared. Okay. And I hope you see why it's 1. So one more time, to be sure you understand what the origin is of this 1 here. That 1 comes from understanding that the sphere is centered at the point x0, y0, z0, so that's that point. So it looks like this, but it's tangent, it's just touching the xy coordinate plane, which means that the z coordinate of the point is the radius of the sphere. So the one that I am pointing to now, here, this z becomes the radius of the sphere over here. And in the picture, it's that dark line segment. So with this in place, this is the setup for the equation. Now we simplify a little. I'll switch to one color. So we have x plus 2 squared plus y minus 1 squared plus 0 minus 1 squared, and all of this equals 1. So now we can take this to be an equation, the equation of our sphere. There you go. And that's the process of finding, the equation of a sphere given a center point and an additional piece of information such as that this one here, so that we know the sphere is tangent to the xy coordinate plane. And if you have trouble seeing that, this will not be the same sphere, but I'll draw a bigger version of the picture so you can see it hopefully a little more clearly. Okay, imagine we have a huge sphere in this octant. There we are. So here's our sphere. Okay, this is the center point, and if we are told that this sphere is tangent to the xy coordinate plane down below, then the radius of the sphere, that segment, becomes, is the z coordinate of the midpoint of the sphere, of the center of the sphere. That's how you reason through this kind of exercise. So that's it. Thank you for watching. Have an absolutely amazing day.